Good afternoon, everybody. My name is Asim Prasad, and I am Executive Director, Corporate Strategy and Corporate Affairs at GAIL India Limited. I hold a BTech degree in Mechanical Engineering from IIT Kanpur, Masters in Business Administration, and Doctorate in Supply Chain Management. In this session, we have 5 speakers altogether, and the theme of this session is organizational readiness, operational excellence, and project management. Incidentally, to give a background, we had 233 abstracts for this supply chain, logistics, and operational excellence stage. And this happens to be the first session under this stage. Subsequently, there will be different sessions as well. So, we have these 5 speakers, and the first speaker happens to be Mr. Alan John. He is Chief Manager, Mangalore Refinery and Petrochemicals Limited. So I will request Mr. John, he can come forward and start his presentation. Thank you.
Good afternoon to one and all. Myself Alan John, representing Mangalore Refineries and Petrochemicals Limited. Thank you, sir, for the brief introduction. And I also thank you, IEW organizers, for organizing this wonderful event. So today's my topic is volume correction factor algorithm as per the latest standards, which will cover the entire gamut of products and the crude used in the petroleum refinery and also aromatic complex. Before going to the details of the algorithm, I would like to touch upon the importance of the volume correction factor. Volume correction factor basically is used for converting the observed volume to the volume at standard base, that is 15 degree, which is followed in India. Unlike other countries where most of them follow 60 degree Fahrenheit, we follow 15 degree Celsius. So even though it is very close to each other, but there is a gap of 1 degree Fahrenheit between them. So hence the algorithm used is more complex. Also, this observed volume is obtained basically from the tank dip or the automatic tank aging, and then using the tank strapping tables, volume is obtained. This volume is again further undergoing corrections based on the water volume, based on the BSNW and the roof weight, etc. So then we will get the observed volume. This observed volume is again further multiplied by the volume correction factor. In short, it is called VCF, to obtain the volume at 15 degrees. So in today's discussion, we will be focusing on crude and refined products. The products I mean HSD, MS and kerosene. These two will come under one category, and then we will also look into LPG and then propylene and aromatic separately. For each of these categories, different set of algorithm is used in the latest standard. So going forward, we will just look at the background of the earlier practices. So earlier ASTM 54AB tables were used. This is a lookup table basically, from which we give input as temperature and density, and we get the volume correction factor directly from the table. But there are a lot of limitations in this method. One is we require interpolation for arriving at the right value, and plus the accuracy also is another limitation. So another problem with this method is it requires more of manual interventions. So let us go forward further. So a need for change has arisen based on the standards evolution, and also unified approach was called for, so that everybody follows the same standard. And then enhanced accuracy. So that is another factor. In the latest algorithm, we are getting 5 decimal accuracy compared to the earlier one, 4 decimal accuracy. And also interpolation, which I was mentioning earlier, is another problem of the earlier standard, which is overcome in this new standard. So coming to today's main crux of the subject. So there are 4 gamut of categories. So crude and refined products is covered under API, MPMS. API stands for American Petroleum Institute. MPMS Chapter 11.1, and this covers the entire category of crude and products. And LPG we are using API MPMS 11.2.4 2019 standard, and then for propylene we are using API MPMS 11.3.3, and for aromatics we are using ASTM D1555 standard. Going forward, the overall algorithm in all these things is basically first inputs are density and temperature, and then in LPG and propylene we will have additional input as pressure. For most of the other thing, only temperature and density is considered as the input, and the output is basically the volume correction factor and the corrected volume at base temperature. So basically first we will cover the crude and refined products, wherein API standard MPMS 11.1 chapter is followed. We will directly go to the flow chart given. So you can see basically we are giving the input of temperature, observed temperature, and the base temperature is 15, and we have the density at 15 degrees Celsius. So first algorithm will what it will do is to calculate the density at 60 degree Fahrenheit. So for that, the flowchart at the right hand side is used, and multiple iterations are done till we get the delta density of less than 10 raised to minus 6. Till that time the iteration will go on, and finally we will get the density at 60 degree Fahrenheit. This 60 degree Fahrenheit is used in the left hand side flowchart, wherein we can get the thermal expansion coefficient from the density at 60 degree Fahrenheit. And from that thermal expansion coefficient, we are calculating the temperature correction factors in the observed temperature and also at the temperature at 15 degrees. So ratio of this temperature correction factors will give us the VCF, volume correction factor, for the crude and products. Now going forward, we are moving to the LPG product. LPG is having some difference from this one in terms of the expansion and also the behavior when the pressure is changed. So in this LPG algorithm, the additional input of pressure is also taken in addition to the observed temperature and the density. So these are the methods. We will directly go to the flow chart of this. So again the inputs are same. In addition to that, pressure input also is there. First density, temperature and relative density ranges are checked and corrected. If it is falls beyond the ranges of the required standard, then the algorithm cannot predict the value. So it will first ensure that the ranges are correct, and then relative density at 60 degree Fahrenheit is calculated from table 23, which is the next flow chart. This flow chart is used for calculating the relative density at 60 degree. So this is a very complicated algorithm. So due to paucity of time, we cannot go to the entire details of the algorithm. But basically, this table will give us the density at a relative density at 60 degree Fahrenheit. From the that relative density, we will be calculating further on CTL. That CTL is temperature correction factor at observed temperature and also at 15 degrees Celsius. The ratio of these two will give us the temperature correction factor overall. And additionally, in this LPG case, API MPMS 11.2.5 also is used basically to arrive at the pressure correction factor. So both these factors are multiplied to get the final VCF. So we'll quickly move on to the next gamut of product, that is propylene. Propylene also is having a unique feature, so it also requires a separate algorithm. So basically API 11.3.3 is used for in this case, wherein there will be a chart basically temperature versus pressure, and using this chart we can directly arrive at the density of the at observed temperature. So density at the observed temperature in pounds per feet cube divided by the 32.068, that is a reference density of the fluid, we will get the VCF factor of propylene. So coming to aromatics, again aromatics also the behavior is different. So for example, paraxylene, benzene and mixed xylene. So another standard set of is evolved, which is ASTM D1555M. So using this standard, there are polynomial equations derived in which the constants vary with respect to the type of fluid used. For example, benzene will have one set of constants, and then the other fluids will have other sets of constants. So these constants are applied and the values are derived, and the table on the right hand side is arrived. So based on this table, we can arrive the VCF for a particular temperature and density. So this is how aromatics products are calculated for VCF. Going forward, the benefits I want to quickly cover here. The approach earlier was table-based approach, and the new one is algorithm-based, that is mathematical modeling. And the accuracy was limited to 4 decimals. Now with the new standard, we are getting an accuracy of 5 decimals. And flexibility in the new one is better because this is algorithm based and it can be easily ported to any platforms like SAP or RTDBMS, etc. And legacy. Earlier system was legacy, and this is now open and it is standardized. And automation is, as I said, it is easy, and we are able to do in-house this algorithm both in SQL as well as C# based program as well as in SAP. And comparing cost, yes, the commercially off-the-shelf product will cost, initial cost will be around 90 lakhs, plus the annual subscription cost of 30 lakhs additional. So we have done it in-house, so there is no cost involved for us. So conclusion, we could successfully migrate all the standards for crude, refined products, LPG and propylene and aromatics. This will cover the full gamut of products for the entire refinery and aromatic complex. So I thank all of you for the patient listening. Thank you.
Thank you, Ellen. Now I would like to invite the next speaker, Mr. Naveen Kataria. He is Manager PDD at Engineers India Limited.
Good afternoon to everyone. Thank you for being here today. Myself Naveen Kataria, Manager working as a role in PDD, Procurement Development Department at EIL. Today I am excited to share a research initiative that directly addresses one of the most critical challenges EPC organizations face across India's energy sector: how we select and evaluate our suppliers. So the roadmap for our conversation will be, we will be discussing about the challenges, what L1 the lowest cost problem in Indian EPC, what the solution we are proposing, the methodology, how we have derived the solution, the ASP model and the evaluation criteria, the pilot testing results. We will talk about how we can integrate it with our procurement decisions, and the implementation roadmap for the pan-wide scale in the organization, and overall recommendation. So what is the challenge? In India's engineering sector have historically relied on the lowest cost bidding system. The logic seems straightforward: select the cheapest bid, save money and move forward. But here is what actually happens. The immediate impact: we prioritize the lowest price tag above everything else. We overlook the critical suppliers factors, capabilities like quality, technical competence, financial health and the risk management above everything else. The real world consequences would be the project often experience delays because the suppliers cannot execute at the complexity we need. There is a lot of rework, supply chain disruptions and poor quality standards, which escalate the life cycle cost beyond what we have saved on the initial procurement. The opportunity what we are missing is global industry best practices from automotive, defense and aerospace have moved away from just L1 models decades ago. They have adopted multi-criteria evaluation framework that balances cost with capability, reliability, quality and risk. So if the world's most advanced organizations have moved beyond L1, why are we still doing it? The solution: we are introducing a data-centric supplier evaluation framework using analytical hierarchy process. It is a sophisticated multi-criteria decision-making tool which is developed and refined over decades, and it helps in strategic planning to engineering project management. What makes this different is the multi-criteria evaluation. It balances cost with other slides in a unified, transparent manner. Scientific scoring: it replaces the subjective gut feeling assessments with quantitative, transparent methodology. Every decision is traceable and auditable. Strategic management: it moves our evaluation from the lowest cost to the best value. It enhances our decision accuracy and improves the life cycle to value. Now, our research follows a 4-phase structure. First was the literature review and benchmarking. Here we reviewed the existing frameworks, academic research on where it is best implemented in the sectors, and then we collected the data from the experts, and the criteria were identified. Then I will talk about the AHP framework development in the later slides, and we did some pioneer testing and the validation result, which I will be sharing. So through stakeholder consultation and literature review, we identified 8 core or the principal criteria that together form a complete picture of supplier capability and risk. First one is the organizational soundness. Think of it as, can we trust the organization? Is the supplier stable? Or do the contractor manage their risk responsibly? So we have to look at the stability, reputation, their governance structure, and risk management practices. If the supplier or the contractor lacks good governance, everything else is at risk. Our projects are at risk. Then for financial stability, we have to look at the liquidity, profitability, creditworthiness, and overall financial health. And there we can address that. Will the supplier be still in business in the next 2 years? Can they finance their growth to meet our demands? Delivery performance. This is about the promises kept, and history is the best predictor. We can check the historical data of the suppliers whether they have kept the promises in delivering at the projects. Quality systems. We all know that the quality issues cascade through the projects. Technical capability factor. Can they actually do what we are asking, or they are technically out of depth? We have to see the design competence, the software, their design teams, their R&D initiatives, or their compliance with our specifications. Capacity to supply. Can they scale to meet our needs, or will they become the bottleneck? So here we can see the production capacity, scalability, and workforce competency. Finally, the logistics and supply chain efficiency. And this becomes important: transportation of ODCs, consignments, cross-country transportations, and even exporting or importing the equipments. And sustainability and compliance. The ESG norms, ISO 14001, 45001, and other ESG programs, are they being implemented at our organizations? This parameter is increasingly becoming critical for global competitiveness and risk management. Breaking down the criteria. Now each of the 8 principal criteria, they are being further broken down into specific measurable sub-criteria. We have listed out 28 criteria on which suppliers can be mapped. This level of details ensures that the supplier evaluation will not be abstract. Procurement teams will actually measure these factors using supplier audits, financial documents, performance records, and third-party certifications. The next step in our methodology was to collect the data from the experts. So how we captured the expert knowledge? We distributed a structured Google form to the 15 domain experts across EL and partner organizations. And they were not academics, they were practitioners from different domains such as procurement, contracts and purchase, vendor development, inspection teams, and the project teams, and the logistic experts. What we adopted was, instead of asking experts to rate each criteria on a scale of 1 to 10, we use pair-wise comparisons. This is the key AHP principle. And why we use the pair-wise comparison? Because when people compare two things directly, their judgments are more consistent and reliable when they try to rate many items on an abstract scale. It is cognitive psychology. We are better at comparing pairs than maintaining multiple rating scales simultaneously. So this is the sample survey questionnaire we had circulated. Here we asked our experts to rate different criteria among each other. For example, we have asked which is more important, organizational soundness or quality systems. And then we asked them to rate on the scale of 1 to 9. 1 to 3 means organizational soundness. The criteria 1 is more important than the other. 5 means they both are equally important. And 9 means quality, the second criteria is more important. So there's the sample form I had circulated. So now I will be talking about AHP methodology. I'm talking about. Let me explain this methodology because understanding it will boost your confidence in the results. So here we did the pairwise comparisons. We compared 2 criteria at a time. An expert will rate the relative importance on a scale of 1 to 9. This creates a pairwise comparison matrix, which I will show you in the further slides. Then we had derived the normalization operation we had done on the matrix. This was done in the matrix algebra. We had done in the engineering mathematics. And this finally derives the final weightages of different parameters, the 8 parameters. And then the consistency check. We have to perform the consistency check of the expert inputs we have received. And the finally weightages are derived from the normalization matrix. Survey responses. So there's the survey responses we had received. You can see that there is a variation. Not all experts see the same importance hierarchy, and this variation is good because it reflects the real difference in the perspectives of people working in different domains, from procurement, vendor development, and inspection teams. And each expert completed the pair-wise comparisons, 28 unique pairs across 8 criteria, and which gives us complete picture on how they see these factors in their decision-making process. And then this was converted to some Sate scale. Sate was the mathematician who devised the AHP in 1970s. And finally, the expert responses were aggregated to create a single pairwise matrix, comparison matrix, and this shows the relative importance between each pair of criteria. You can read as like we compare the organizational soundness with the financial stability, it comes out to be 2.18. It means that organizational soundness is rated 2.8 more important than financial stability. And on this matrix, normalization operation was done, and from this the final criteria are being calculated in the final column. And then we had done the AHP consistency check, because now you will ask that are these expert judgment actually consistent? So because when 15 different people give different pairwise ratings, we need to verify that their overall pattern of judgment is logically consistent and not random or contradictory. So we did the consistency index check, then the random index, and the consistency ratio. These are mathematical formulas, but finally I can say that the consistency ratio we had calculated was 5.79%, and which is less than the acceptable threshold of 10%. So we can say that the expert judgments were highly consistent. Their opinions were not random or contradictory. Instead, they form a coherent logical pattern, even though different people emphasize different criteria. So this is the final selection criteria. This balance reflects the reality of the EPC projects. Technical and operational excellence matter as much as the financial metrics. And our framework distributes the importance across 8 dimensions. There's the pie chart of the various 8 factors. So this visualization makes the weightage structure immediately clear. Visually, we can see that the top 3 criteria, organizational soundness, quality systems, and technical capability, are nearly equal, and together they are above 50%. The next 2, delivery, financial, are also equal, another 28%. The remaining 3 are small, but they are meaningful. So for procurement teams, now when they evaluate the suppliers, they have to spend energy on these 8 dimensions. Now don't just ask what is the lowest price, ask is the organization well managed? Do they have ISO certifications, quality processes, and improvement culture in their workplace? Can they actually design and deliver what we need? What is their delivery track record? Are they financially sound? And then finally, what is the price? The pilot testing and the model validation. That the research on paper is one thing, real world validation is another. Our pilot study, that we tested this framework on the historical procurement data from 5 fabrication equipment suppliers at EIL. What is the process? We selected the suppliers with diverse performance profiles. Some were excellent, some problematic, and some average. We scored each supplier on all the 28 parameters. We took the financial data from annual reports, quality data from inspection records, delivery data from project completion records, technical data from the specifications, the data sheets, and the drawing compliances, and organizational data from our audits. And we calculated the composite AHP score for each supplier and compared the AHP score with the project outcomes. We found the framework successfully differentiated the supplier performance and aligned strongly with the project execution outcomes. The indicative outcomes I'll share. These are early findings, but they are very, very promising. Result number 1, 15% reduction in evaluation cycle time. A procurement cycle that took 60 days now takes 51 days. And for organizations doing hundreds of procurements yearly, that is thousands of man hours saved. 20 to 25% potential cost avoidance, which can be done from the better supplier selection, early rejection, flagging non-compliant bids before they consume the resources, reduce risk. We are better able to manage our risk. 87% alignment with the project outcomes. This is the validation metric. Did suppliers with high AHP score actually perform well on projects? 87% alignment means the suppliers we had scored higher, they actually performed well, and the supplier we scored low actually had issues. This framework is predictive and not just descriptive. So this is the supplier evaluation dashboard. This is the user interface procurement teams will see once the proposed framework is live. Why dashboard? Because they can assess the supplier in seconds. Visual design helps in quick decision making, and it can be integrated into ERP systems for real-time updates. And this score can be classified, can be used to categorize the suppliers in the 5 levels like grade A, B, C, D, E. For grade A, can be strategic partners with proven excellence. They are the suppliers who we can grow with. We can do the R&D initiatives with them and the long-term contracts. The 5-tier system enables differentiated supplier development. Not all suppliers can be grade A, but we can systematically help the suppliers to move above the ladder. Now linking for procurement decision. So we can use these scores in the tender evaluation, the bidding, shortlisting of bidders, the price comparisons, awarding of the contract, and order monitoring. The composite scoring model. Now let me walk through the math of this composite scoring model. First we need to define the weightages between the quality and the cost split. Then the supplier AHP scores have to be normalized on the scale of 0 to 100. Then we have to collect all the bids from the suppliers, and that bids have to be normalized on the scale of 0 to 100. Then we have to calculate the composite score. The supplier with the highest composite score wins, balancing quality and overall cost. So this model balances value, quality and capabilities with cost in a transparent and an auditable way. What is the implementation roadmap? So rolling out this framework pan-organization wide requires a structure. So what is the first phase? We can deploy this into one procurement category and work on 2 to 3 live tenders. We can train the procurement teams. Then the phase 2 will be, we can integrate it into our ERP integration model or the SAP. And the final implementation will be quarterly reviews, feedback loop arrangement, and the full deployment. Strategic value creation. There are quantitative and qualitative benefits like the higher supplier selection, reduce overruns, risk reduction, cost optimization, operational excellence, and whatnot. I see that it is always beneficial. Industry-wide recommendations. They can transition to multi-criteria procurement, develop sector-specific hierarchies, because this model is sector agnostic. They have to implement the phased rollouts, deploy supplier grading mechanisms, establish the governance and the blacklisting protocols, and drive continuous refinements. And this framework is sector agnostic. So basically we can see that you can keep the framework structure same, but adjust the weights to reflect what actually matters in your industry. So blueprint for procurement excellence. This is a strategic shift from a transactional to transformational procurement. Instead of asking who's the cheapest, we ask who delivers the best value. Instead of hoping suppliers will be good, we select them systematically proven capabilities. Instead of reactive quality management, we build quality in through supplier selection. Whether you are in APC, renewables, power, or manufacturing, I challenge you to look at the current supplier selection process. If it is primarily based on price, you are leaving value on the table. Consider adopting AHP or similar kind of MCDM techniques. Test with pilot procurements. I am confident you will see what we saw. Better suppliers, faster execution, lower life cycle cost, and stronger competitive positioning. And together we can establish India's EPC sector as a global benchmark. Thank you for your attention today.
I will call upon Aayushi Bhatia, Deputy Manager SECI, for her presentation now.
Thank you, sir. Good afternoon, everyone. So I am Aayushi Bhatia, working as Deputy Manager Corporate Planning in Solar Energy Corporation of India. So Solar Energy Corporation of India is a renewable energy implementation agency set up by Government of India and working under the ambit of Ministry of New and Renewable Energy. So today I am here to present my paper on integrating principles in renewable energy project with a case example of a solar energy project which our organization is implementing in Ranchi. So India's renewable energy transitions presents a critical challenge in terms of integrating environmental, social and governance principles across the full project life cycle. Solar Energy Corporation of India, as India's premium renewable energy implementation agency, has played a pivotal role in following these principles in its own projects, which are the CAPEX projects being set up by the company. They are responsibly, in addition to the responsibility of capacity addition, we are also following responsibility of environmental stewardship, social inclusion, and transparent governance. So as on date, like as on 2025, we have signed PSAs for 73.8 gigawatt of capacity and awarded renewable energy projects of this capacity, and we are signing 25 years of PPA with long-term power agreements. So now to cover the environmental perspective. So SECI embeds biodiversification and resource efficiency into project designs and executions. So measures such as underground cabling, bird diverters in ecologically sensitive regions help protect these great bustard Indian birds. So, so these principles have helped nurturing the nature in natural way while taking care of the targets being set up by Government of India. On the social front, SECI engages with the community before putting up the project at any site and follows the FPIC protocol, which stands for free, informed, and prior consent with the public. So wherever we are setting up the project, before site selection, we take the community on board, and then we go for the setting up of project. And along the life cycle of the project also, we take care of the local community by providing them livelihood in the way they can and by providing them the training sessions. So I will again emphasize on this particular example in my case study project, which is as I mentioned in the Gator suit. Next comes the e-tendering, which SECI adopts in all its tenders. So we follow transparency through digital innovation. Are all the bidding, we have a transparent digital auction platform which has revolutionized the procurement, driving lowest tariff in the market and attracting investments. This has also gained investor confidence during the process. All bidding and contract awards occur online during all the phases, and this eliminates irregularities, if any, in the auction process. So this unique business model extends to all the emerging renewable energy sectors like green hydrogen, which has again achieved a record low tariff in the sector. And this has ensured that the competitive pricing and market confidence is gained in low time. This I have already explained that how we do the ESG integration during the project life cycle, and I will be explaining it in detail in my project case. So this is the Gator solar project. So right now we are setting up a 100 megawatt floating solar project. So how we are implementing or taking care of the ESG principle in this project? This project is located in Ranchi, Jharkhand, and we in terms of the spatial arrangement, this project occupies only less than 1/10 of the area. So this from the spatial arrangement also it follows the environmental sustainability angle. Now coming on to the details of how it has followed the ESG. So first one is environmental stewardship. So continuous EHS monitoring is being followed at the site. Yeah. So as it is a reservoir, we have a dedicated team which monitors the dissolved oxygen and salinity for aquatic life there. And there's also a plantation drive which happens every 3 to 6 months to take care of the local flora and fauna. Then there's a livelihood co-creation also. As it is a reservoir, so there is a culture-based fishing which was happening. So we have provided to the local livelihood, we have provided around 15,000 fingerlings we have provided around 100 cages, while each cage entails 15,000 fingerlings. And we have also provided the system for providing cages as well as feed for next 10 months of the project. Next is institutional building. So as we know that in rural areas there's a lot of institutional void which happens in coordination with the central government. So we have created a FPO known as Akshay Oja Mission in support with NABARD fund, and all the 21 members of that FPO are women members, showing inclusiveness from the society. and that is how efficiently it is working. So now this FPO has got access to all the central government ministry for its day-to-day level work. Wherever they want to reach out to the central government, they can reach out through this FPO and they get a quick response as compared to the earlier times. Community empowerment I have already mentioned. It is apart from this fisheries segment, we are also creating trainings and livelihood for piggery and goatry, and we are also doing some medical camps for the local people. So how we can strengthen this ESG leadership in the coming time? First one is strengthening the community protocols. As I mentioned in the Geta Sud one, that institutionalization of the local arrangement is very, very important because it has to reach to the central government. So as we follow the FPIC process, it has helped us in onboarding the local community for this purpose. Second is formalizing the ESG metrics, then enhance the environmental oversights, which essentially means that taking care of the environmental angle of the site. As I had mentioned that with the 18,000 hectare of reservoir, we are only doing 8 to 9% in which we are setting up this floating solar plant. So now coming to the key takeaways. So ESG integration has strengthened the project resilience, social resilience, and investor confidence in all the renewable energy projects. And this transparent governance, which happens through e-auction, has driven the record low tariffs and competitive markets in the renewable energy sector. Biodiversity protection and community benefits has created long-lasting impact on the community, also local community. And this has also fastened the achievement of India's 500 gigawatt goal required for coupling technology with ecosystem stewardship, as we have got the confidence of the local community, and we are able to mitigate the hurdles being created at that particular point. So thank you for taking your time.
Our next speaker is Mr. Aakash Chuchra. He is senior geophysicist at ONGC.
Good afternoon all. I am Aakash Chuchra. I am working as a senior geophysicist with ONGC, and I'll be presenting this a seismic attribute based workflow for pre-drill assessment of mud loss zones in carbonate reservoirs. Just to set the context, mud loss in the carbonate reservoirs is mainly caused by the natural fractures or the works or any porous zones which are created by diagenetic processes, including dissolution or dolomitization. What it causes is that these features cause certain permeability pathways which causes the drilling fluids to enter. And this is a problem with the drilling. This can cause drilling hazards as well, because this causes wellbore instability. This increases the non-productive time in drilling. So what we have done in this study is we have adopted a seismic attribute-based workflow to characterize the areas and characterize the areas which are more prone to mud losses, or which are basically weak zones, and we have calibrated it with the drilled well data available with us. So the study is basically from an Indian basin only, and this area spans around 450 SKM, and we have 3 wells drilled in this area. We have nomenclatured as W2, W1 and W3. Here in this electrolog correlation profile, we are showing these 3 wells, and we have correlated the major markers, major formation tops, A top, B top, C top, D top, and within C as we have C1 and C2 subdivisions. So we are focused on the AB zone between the A top and the B top. This is mainly dominated by limestone lithology, and in the drilled wells, we have encountered heavy mud losses in this zone. In W3, if you observe, the caliper log also shows bad hole conditions, and we have encountered very heavy mud loss in the lower part of this AB zone. In W1, we have encountered mud loss in AB zone as well as top part of the BC zone. But when we analyze the casing policy, we observe that the AB zone was also open during drilling of the BC zone. So we attribute that this mud loss could be from AB zone only, as indicated by the caliper log. However, in W2, this is the most stable well in this area, which has reported very few mud losses. So these observations we have tried to characterize through our seismic responses. For that, what we have done is we have generated a random seismic line through these 3 wells. And here you can observe that we have also highlighted the zones where mud loss has been observed in the pink color. So the lower part of AB zone that we are trying to focus on. For that, we have correlated A top and B top heads as horizons, and within that we have created certain proportional slices. And slice 5, which corresponds to the top of the porous zones, this has been used for the attribute analysis for the further studies. For the bare eyes, we observe certain amplitude difference as we go from W3 to W2, where W2 encounters some relatively higher amplitudes, and W1 and W3 they show lower amplitudes, which are basically because of the weak zones there, which are contributing to the mud losses. These are the porous zones which has caused this seismic response. So between slice 5 and the B top, we have extracted this RMS amplitude slice, and this also clearly demarcates the areas where we have the lower seismic amplitudes, which are more prone to the mud losses. And as compared to the well W2 falls in relatively higher amplitude area. That is why that well is the most stable one. So this was further validated with the cross plot of the P impedance and the neutron porosity. So this cross plot indicates that the lower part of AB zone are characterized by lower P impedances, which are mainly because of the porous zones there, and they are also characterized by higher neutron porosity, which indicates the hydrogen rich fluid zones basically. So this cross plot is encouraging enough for us to go for the prediction of these properties to characterize these weak zones or the porous zones. So a model-based post-stack inversion was carried out, incorporating all the 3 drilled wells in the area, which was followed by the neutron porosity prediction using multi-attribute regression analysis, in which we gave input of around 15 attributes, and the model optimizes the number of attributes to give us the best correlation with the original neutron porosity log. So the neutron porosity prediction was done with a confidence of around 79%, which is a good number. So then once we got these volumes, we analyzed these volumes and we calibrated them with the drilled well data for some certain conclusions. So firstly, we got the P impedance volume. Again, if you observe in the zone, in the lower part of the AB zone, there is a clear-cut low impedance layer which continues from the well W1 to W3. And as we go towards W2 in the southwestern part, the impedance is relatively higher. So this again validates the observed well data observed, or the observations from the drilling of these 3 wells, that W1 and W3 may be drilled in the area which are more porous or more weak, more mechanically weaker areas. That is what has led to the mud losses observed in these 2 wells. And as compared to that, W2 is falling in relatively higher impedance area, and that is why this has been the most stable well among these 3. So to further see it spatially, we have extracted the mean P impedance slice between this slice 5 and formation B top, and this highlights the areas where we have the lower impedance and where we have the higher P impedance, and the well data supports the drilling observations. The next attribute which we predicted was the neutron porosity. Neutron porosity basically is indicating the fluid rich zones, the hydrogen rich zones. Again, if you observe the random line, if you observe the seismic section, from W1 to W3 we have relatively higher neutron porosity zone in the lower part of AB. And as we go towards W2, we have relatively lower neutron porosity zones. So this again is validating the drilling observations, which is very much in line with the basic seismic attribute response and the P impedance response as well. Since we had these two quantitative properties, what we did is we applied. Sorry. Yeah, since we had these two quantitative properties, we applied certain cutoffs which we got from the cross plot itself, that the zones or the areas with the P impedance lower than 9,000 gram per cc into meter per second, and the areas with higher neutron porosity, basically 0.3, that we have segregated, and you observe that the lower part of the AB zone shows the red streak, which has these lower P impedance and high N5 values. This continues from W3 and to W1, but as we move towards W2, the zones are relatively stronger, or the zones are having relatively higher P impedance and lower neutron porosity, which again validates the drilling observations. So what we conclude from this is that we have adopted a seismic based workflow which can be implemented in any such carbonate reservoir area, carbonate dominated reservoir area, and this can help us to predict the zones which are more prone to mud losses, predict the areas where we are more susceptible to encountering weaker sections, and we can further plan the wells. We can plan the well bore stability. We can plan the drilling muds. So that may help in reducing the non-productive time, and that will make basically our organization more ready for the further exploration and development activities. Thank you.
Thank you, Akash. Our next speaker is Angela Patricia, PMO, Operations Planning Optimization, Deputy Manager at Mansarovar Energy.
Okay, welcome everyone. So I'm going to talk today about the structure methodology for delivery of handover of oil fields. Okay, so in our industry, we are really good in doing projects, planning, and everything but regarding our core business, the operations and the projects regarding operations. It's moving. Okay, so with this, we are focusing on that, on how we do projects of our core business. However, we need also to review how to address or how to dimension when we are going to face a termination phase of a contract. So we need to also review how to plan, how to make risk mitigation plans for the delivery of our assets. Termination of the contracts are not only or not simply a legal milestone for our oil fields. We also need to focus on how we are going to do. Here, the big question is, how can operators approach the termination of the contracts in a way that is structured, that is valid, that is like value-driven for the company? Okay, so my name, Angela Gonzalez. I'm the Deputy Manager of PMO, Operational Planning, and optimizations in Mansarovar Energy is a Colombian company. So I'm going to talk to you about this joint venture. So a NARA association contract was signed in 1980 between the national government company in Colombia and a private partner. This has several private partners, but since 2006, Mansarovar Energy, which is a joint venture between ONGC and Sinopec, assumed the operation of the field. With this, we also start all the activities and the development of the field, and in 2021, we face the termination of the NARA association contract. So with that, we start all the activities to plan how should we face this situation for the company. So in Mansarovar, we create a structure framework of how can we handle this delivery, and we make a project for the whole life cycle. In this, we make 3 stages or 3 phases. The first one, diagnosis. In diagnosis, the most important thing is to review what we need to do to finish this assessment of the handover of the fields and all the assets, to review the ground lines and the baselines to do this. In the implementation phase, the idea is to execute all the activities that were planned to fully and properly deliver the fields. And in the last one, in the post-termination phase, is to continue the closure of all the activities that we must do. Implementation is till the end of the contract, and post-termination is as soon as we deliver of the assets, the activities that are remaining to close the contract. Here we must navigate in complexity situation or in complex situations. I'm going to show you, and I'm not going to focus here on how to do projects. I'm going to focus here on lesson learned that we have, and also activities that you may face if you're going to have a termination of the contract. The first one, as you can see, are the blockades of the community. And we pass, you can see 2019, in which we have 9 blockades of around 0.5 days. And at the end, or at the termination, we face 17 blockades, and even 1 blockade that was around 37 days. So this is one of the huge important points that we must use. Also, investment, how to recover or how to make our investments values. We also union growth in the community or in our employees, the union growth. You can see also the trend in the chart, in which we passed from 4 unions to around 9 unions in the termination phase of the contract. Also, number of people in the unions rise from 283 to around 395 persons. Inspections, we face a lot of inspections from environmental entities, government entities, so we also need to deal with this. And occupations, the growth of occupation and people in the houses or invasions that we face in the field. And reduce of maintenance, how we face this. Remember, we were in 2021 in COVID-19 era, and we reduce, because of this situation, the maintenance. So we also need to face that. Resulting of that, we accelerate the process of deterioration of our fields. So we also need to face this situation. For takeaways and lessons learned of this project, we have different strategies. Personal strategy, the voluntary retirement plan, how to make the transition for the employees easier, how to make conversations, so you must have conversations transparent and structured with all your workforce, how to help people for the outplacement of, or the situation that they are going to face with the termination of the contract. Also, please focus on the formalization of ground rules, principles, and criteria to face this termination of the contract. Early validations of all the activities, the bail and the commitments that we have, is important to do it since the beginning. Negotiation strategies. Be proactive on the development of negotiation strategies. Remember, you here are going to face situations with the community, with the new owner or the one that is going to receive the assets, also with your employees, internal situations. So negotiation strategy must be faced since the beginning. And also how is going to be your position in disagreements. You're going to face situations in which you are not aligned with the company or the person that is going to receive the assets. So you also have to plan how you're going to face disagreements. Proactive social management. Remember that here you're going to face situations with the communities that are surrounding you. So early alignment of the community, define strategies, define what situations can have or what situations you're going to face. The baseline definition, review the activities that you must do, review the scopes that you must face, and also manage this termination as a portfolio management strategy. You can divide all the activities that you must do into topics. Here is an example of the topics that we use: environmental, safety, financial status, legal commitments that you have, how you're going to deliver of the information and the knowledge that you have during this year, because you need to transfer it also to the new company. Labor, auditing, and other regulations, the purchase and contracting, the contracts that you have in the operation. So here is important to have that. Some takeaways that I want to keep with you is, remember, this determination is not only a legal situation, it's a project that you must face, you must plan, and you must review the risks and the situations that you are going to face. Also, early planning. Early planning and ground rules are fundamentals for the proper delivery and the proper situation to handle the assets. Governance and structure in the project. Be clear with the situations, the scope, and the information that you're going to transfer, how, when, and where you're going to transfer all the information. Social, labor, environmental. Be clear with the stakeholders that you have. Be clear with the planning internally and external of how to face situations, and treat the handover as something that you need to face since the beginning, the preparation, until the end when you finish all the activities that you must do. So thank you. This is a way how we manage the situation of a delivery of around 40 years contract, and how we are doing, and the lesson learned and the ground rules that we are sharing with you to have these activities. Thank you so much.
Thank you, all speakers. And we had a very diversified presentation